Rust. It's everywhere. No matter where you look, whether it's in your backyard, on the street, or even in the park, chances are you'll spot something that's been touched by rust. It creeps up on metal surfaces slowly but surely and leaves its unmistakable mark. Ever seen an old bike or a forgotten garden tool covered in a reddish-brown crust? That's rust in action. It's not just a sign of age or neglect, it's a clue that a chemical reaction is taking place right before your eyes. Rust shows up on iron or steel left out in the rain, or even just in damp air. All it takes is a little moisture and some oxygen, and the process begins. Even a humid day can be enough to start the transformation. Rust is a transformation, not just a stain. It's the metal itself changing at a molecular level. What starts as a shiny, strong surface slowly becomes flaky, brittle, and weak. It's a dramatic change, and it happens more often than you might think. Take a shiny new nail, for example. Leave it in a puddle, and before long it becomes flaky and weak, its surface eaten away by rust. This isn't just a cosmetic problem. Rust can destroy the strength and usefulness of metal objects. This process, called corrosion, is chemistry in action, happening all over our planet. From the smallest screws to the largest ships, no metal object is completely safe from rust. It's a global phenomenon, affecting everything from household items to massive structures. It's a constant battle between the things we build and the forces of nature. Every metal bench, bridge, or tool is in a silent struggle against rust, trying to resist the slow but steady attack of air and water. The next time you spot a rusty car, an old anchor, or even a playground swing, remember? You're witnessing a fundamental chemical process at work. Rust is everywhere, quietly shaping the world around us. Even the strongest materials like thick steel beams or heavy chains can be broken down by something as simple as air and water. Over time, rust can turn solid metal into fragile flakes, showing just how powerful nature's chemistry can be. Understanding rust isn't just for scientists or engineers, it helps all of us appreciate the hidden forces at work in our everyday lives. By learning about rust, we can better protect our belongings and even design stronger, longer-lasting materials. From simple tools to massive bridges, rust tells the story of how nature constantly tries to reclaim what we build. It's a reminder that nothing lasts forever, and that the environment is always interacting with the things we create. So what's really happening when metal rusts? What's going on beneath the surface as that orange-brown layer spreads? Let's find out together. It's not magic, it's science, unfolding right before our eyes. The next time you see rust, you'll know there's a fascinating story behind it. So, let's dive into the chemistry behind rust, and discover how this everyday phenomenon reveals the hidden power of nature. We see rust everywhere, but what is it really? Why does metal rust? The most common rust forms on iron and steel, because iron loves to combine with oxygen. Iron atoms are more stable when they bond with oxygen, which is everywhere in the air. This natural attraction is the driving force behind rusting. Rusting is a chemical reaction. Iron reacts with its environment and turns into iron oxide. So when you see rust, you're seeing iron transformed into a new substance. Metal rusts because iron wants to return to a more stable state by bonding with oxygen. It's a natural process, like an apple turning brown. But there's another key ingredient that speeds things up. Let's look at the full recipe for rust. Ready for the secret ingredient? To create rust, you need 3 essential ingredients: iron, oxygen, and water. These 3 elements work together in a fascinating chemical process that transforms shiny metal into that familiar flaky reddish-brown coating we call rust. But why do these particular ingredients matter, and what role does each one play in the process? Let's break it down. Iron is the key player here. It's the metal that undergoes the transformation. You'll find iron in everyday objects like cast iron pans, steel beams holding up buildings, or the body of an old car. When you see rust, you're seeing iron reacting with its environment. Without iron, you don't get that classic reddish-brown rust. Other metals like aluminum or stainless steel don't rust in the same way. That's why iron and its alloys are especially vulnerable to this process. Next, oxygen. Oxygen makes up about 21% of the air we breathe, and it's all around us. Invisible but ever-present. It's the oxygen in the air that reacts with iron, starting the chemical changes that lead to rust. If you were to keep a piece of iron in a vacuum, with no air at all, it would stay shiny and untouched for years. But as soon as you expose it to air, the reaction can begin and rust starts to form. The third ingredient is water. Water acts as a catalyst, speeding up the rusting process. Even a tiny bit of moisture in the air can be enough to get things started. That's why you'll often see rust forming faster in humid environments or after it rains. That's why metal objects left outside in damp places, like a garden fence or a bike after a rainy day, rust much more quickly than those kept indoors or in dry climates. The more moisture in the air, the faster the rusting process. Water doesn't just speed things up, it actually helps electrons move from the iron to the oxygen. This movement of electrons is a critical step in the chemical reaction that creates rust. So, the recipe for rust is simple. You need iron, oxygen, and water. When all three are present, rusting is inevitable. If you take away any one of these ingredients, if you keep iron dry or seal it away from air, the rusting process slows down dramatically or even stops altogether. That's why metal objects last much longer in dry, desert climates, where there's little moisture in the air, compared to wet coastal areas where rust can destroy metal in just a few years. Understanding this simple recipe is the key to both causing and preventing rust. If you want to protect metal, you need to control its exposure to air and water, or use coatings and treatments that block these elements. Now let's zoom in and see what's happening on a microscopic level. The real magic of rust happens at a scale too small for our eyes to see. Ready for a closer look? Let's dive in and explore the hidden world where rust begins. Let's zoom in. When iron, oxygen, and water meet, a tiny electrochemical reaction begins. A droplet of water on iron acts like a mini battery. In one spot, iron atoms lose electrons and become positive ions. This is the anode. The lost electrons travel through the metal to another spot, the cathode. There, oxygen and water use the electrons to form hydroxide ions. Positive iron ions and negative hydroxide ions attract and combine to form iron hydroxide. This compound reacts with more oxygen to become hydrated iron oxide, rust. The strong metal turns into a flaky, reddish-brown substance. All this happens invisibly, but it's constantly at work wherever iron, water, and oxygen meet. That's the science behind rust's transformation. Let's put this into chemistry language, a chemical equation. The basic formula iron plus oxygen plus water makes hydrated iron the 3 oxide. In symbols, Fe plus O2 plus H2O, Fe2O3 NH2O. Sometimes the reaction forms iron the 3 hydroxide first, 4 Fe plus 3O2 plus 6 H2O, 4 Fe OH3. These equations show the exact proportions needed for rust to form. 4 atoms of iron react with 3 molecules of oxygen and 6 of water. Chemistry is about these precise relationships, like a perfect recipe. Seeing the equation helps us visualize how atoms rearrange to create rust. It's the blueprint for this everyday transformation. Understanding the equation helps us control or prevent rust. Now, let's see why rust is such a big problem. The consequences go far beyond a rusty nail. Rust is more than just an ugly orange stain. It's a chemical process that turns strong, solid iron into weak, crumbly flakes. What starts as a tiny spot can quickly spread, eating away at metal from the inside out. Over time, this seemingly harmless process can cause serious damage, and it's a problem that's much bigger than most people realize. Iron and steel are the backbone of our modern world. We use them to build bridges that span rivers, cars that carry us everywhere, and tools that help us get work done. These metals are chosen for their incredible strength and durability, but when rust takes hold, that strength disappears. Rusted metal loses its ability to support weight, which is bad news for anything that needs to stay sturdy and safe. Even a small amount of rust can weaken a structure over time. Take bridges, for example. These massive structures rely on solid steel beams to hold up thousands of cars and trucks every day. If those beams start to rust, the entire bridge can be put at risk. Rust weakens the metal, making it brittle and prone to cracking or even collapsing under pressure. The consequences can be catastrophic, leading to dangerous accidents and costly repairs. That's why engineers and maintenance crews are constantly inspecting and repairing bridges and other metal structures. Regular maintenance is the only way to catch rust before it causes real harm. But rust isn't just a problem for big infrastructure. It affects our daily lives too. Cars, tools, pipes, and machines, all of them can fall victim to rust, leading to breakdowns and expensive replacements. In places where winter roads are salted to melt ice, rust can attack cars even faster. Salt speeds up the rusting process, eating away at car bodies and frames and making vehicles less safe to drive. Rusty pipes can spring leaks, causing water damage and wasting resources. Machines with rusted parts can break down unexpectedly, leading to lost time and money. The economic impact is staggering. Every year, billions of dollars are spent worldwide to fight rust, repair damage, and replace ruined equipment. It's a hidden cost that affects everyone, from governments to homeowners. All that money, time, and effort goes into battling what is, at its core, a simple chemical reaction between iron, water, and oxygen. Yet the fight against rust never really ends. Rust may look harmless, but it's a massive, expensive problem lurking just beneath the surface of our everyday lives. It affects safety, reliability, and the economy on a global scale. No one is immune to its effects. So, how do we fight back against this relentless enemy? What can we do to protect our metal structures and possessions? Let's take a closer look at the strategies and technologies we use to prevent rust and keep our world strong. To stop rust, we block one of the ingredients: iron, oxygen, or water. The simplest method? Paint. It seals metal from air and moisture. Oil or grease coatings also repel water and protect metal. For heavy-duty protection, we use galvanization, coating iron with zinc. Zinc corrodes first, sacrificing itself to protect the iron underneath. Stainless steel is another solution. Mixing chromium into steel creates a protective layer that resists rust. That's why kitchen sinks and cutlery stay shiny. For big structures, we use cathodic protection, attach blocks of zinc or magnesium to steel. These sacrificial anodes corrode instead of the important metal. They're replaced every few years, saving pipelines and ships. All these methods are about outsmarting rust's recipe. By blocking air, water, or changing the metal, we keep rust at bay. But sometimes rust is actually useful or even beautiful. Rust isn't always the villain. Weathering steel, like Corrosion, is designed to form a protective rust layer that stops further corrosion. Artists and architects use it for its earthy look in sculptures and buildings. Mars is called the red planet because its surface is covered in rust. Iron oxide gives it that color. The iron in your blood also bonds with oxygen, giving blood its color and metallic taste. Rust can even be green. In certain conditions, iron forms greenish oxides, and copper corrosion turns statues like the Statue of Liberty green. Not all corrosion is reddish-brown. Chemistry creates a rainbow of effects. Rust is everywhere in more ways than you think. Why does rust matter? Because iron and steel are the backbone of our world. Understanding rust helps us protect bridges, cars, ships, and pipes. Knowing the chemistry lets us invent better paints, coatings, and alloys. It saves money, resources, and keeps us safe. Rust is a reminder that even our strongest creations are vulnerable to nature. It connects the tiny world of atoms to the massive world of engineering. Next time you see rust, see science in action, and our ongoing battle to outsmart it. Science is everywhere.